Hi, I'm Martin from Device Solutions, and in this video we're going to take a look at the digital I/O features on the Opal development kit. The kit has 4 protected digital inputs and 4 digital outputs for connecting to external circuits. Both the digital inputs and outputs operate at 5 volts, with the outputs capable of sourcing up to 1 amp. They also include LED indicators to show when a port is active. The Opal Dev Kit also has 2 push buttons and 2 LEDs, which are available for use in your application, along with 3 analog inputs. To help you wire things up quickly, we used push wire connectors. These take 18 to 24 AWG solid and stranded wire. Once you have stripped off the insulation, simply push the wire into the connector. To release the wire, we have included a tool with the kit. Push this into the hole and pull out the wire. The 2 CAN bus channels on the Opal Dev Kit also use the same connectors, and we have another video which demonstrates this feature. Next, I want to show you a quick demo of the digital I/O in action. This demo uses Windows Embedded Compact 7 and is coded in C++. Gurus, our OS partner for Windows Embedded Compact, also has C# wrappers, which gives you access to all the Opal functions from the .NET Compact framework. For the demo, I've connected a buzzer to output 1 and then the signal back into input 1. A thread checks for the user button 1 to be pressed, then activates output 1. A separate thread looks at input 1, and if that is high, it turns on user LED 1. User button 2 will exit the application. Let's take a look at the code. The code is very simple and does not include all the error checking that you would have in a production application. First, we set up the GPIO, which includes calling the GPIO init function. You must do this before calling any of the GPIO routines. Next, we set up each GPIO we are going to use. I have created the setup GPIO function to wrap up the configuration tasks. Taking a closer look at this, we see there are 2 parts to setting up a GPIO pin. The first involves setting up the configuration, and we must get the default values before making any adjustments. Once the port and pin values are set in the structure, we call GPIO getConfig to retrieve the data. We can now set the desired direction and call GPIO setConfig to write this back to the GPIO registers. In the second part, we set up the GPIO structure with the port and pin and initial value. Writing to a GPIO involves setting the value and calling GPIO write pin. Going back to the main program, you see we have 2 threads which perform all the work. These execute very similar code. Let's look at the button thread. The first thing that happens in the while loop is that we read the button 1 input. As you can see, this is done by calling the GPIO readPin function, which causes the value field to be set. The GPIO value for button 1 will be 0 when the button is pressed, so we need to invert this before setting the value of output 1. As you can see, connecting to external circuits and accessing GPIO from your application is very easy with Opal. You can find out more about the Opal module and development kit at devicesolutions.net.